Hello, all, good evening. Thanks for your time and thank you for joining this session. So today we'll be starting our webinar on Teamcenter DevOps. As a part of that, we'll see what are the base practices when it comes to DevOps and how to implement those in Teamcenter. So this is going to be a brief agenda where we will first go through the challenges. So with respect to current Teamcenter implementations, what are all those challenges that typically uh, team PLM team come across? So we will start with the challenges. When Teamcenter Deployment Center, this is I would say one of the recent tool which is being developed by Siemens, and this is explicitly with respect to uh, deployment options for complex software like Teamcenter. Then we'll see the DevOps. So DevOps in general, and then what are the uh, various building blocks of the DevOps, and then implementing the DevOps in Teamcenter. So to perform this activity, what are all those things that we'll have to see that we'll see, and then the business use cases. So we'll see various scenarios which typically uh, you know which typically occurs uh, while implementing Teamcenter software. So we'll see like how these use cases can be implemented through DevOps along with deployment center. Before that, I'll take a couple of minutes to actually start our topic. So let me just take this moment to introduce Next PLM Solutions. So we are leading PLM services and research for the company. So we have expertise in Siemens PLM product suite, where we have a multidisciplinary industry experts across industries and uh, across solutions. We have in-depth expertise and experience, and we basically offer cost-effective solutions to the customers. So these are the offerings we have. So we have expert in Teamcenter cybersecurity, where we do the implementations like single sign-on, DRM, then PKI, security audit, then expanding existing PLM implementation to the next level. So like it's like implementing the additional solutions like product configurator, eCAD integration, partner correct, Mendix, uh, P4X, then migrating rack use cases to active workspace. Since we know rack is something that's it's kind of a legacy client, so migrating your rack functionality to active workspace, this is something we are expert in. Redefining the solution, migration from legacy system to PLM, so data migrations, migration from on-prem to cloud, high-end consultations, and then most up-to-date resource. So now let's go to the topic, that is the Teamcenter DevOps. And as we have seen in the agenda, we start with the challenges. So there are, when it comes to Teamcenter, managing Teamcenter side, there are various challenges that we have seen. So of course, like this list is not limited to these challenges, but I have listed the most often. So delay in developments. This is, I would say, delay in deployments. We know, right? Teamcenter is a complex enterprise software where it is maintained by team across different environments, and that different environment itself, it leads to delays in deployment solutions. To deploy any specific solution, we have to deploy it to other environments. So whether it is developer development environment, test environment, quality, and then ultimately it goes to production environment. Since it involves, we are actually performing same thing again and again. So it's kind of we are performing multiple iterations. and it basically delays the overall deployment process, and ultimately it impacts the business. So, uh, and it basically causes the impact. Environment stability, there is always that sense of instability while managing multiple team center environments. For example, performance issues or the data issues. Uh, there could be various or specific data conditions where specific use cases they don't work, and in these cases you have to rely on specific environment uh, to perform or to validate that use case, and ultimately it leads to environment instability. Then quality, multiple issues basically it leads to degraded quality in overall solution implementation. So whether it is bugs or any kind of critical issue that basically halts the overall business processes. Too much manual activities, or we can also say that no or minimal automation. Most of the times, while working on Teamcenter environments, we basically, as a team, we are involved in multiple manual activities. So whether it is you take any activity with respect to Teamcenter, we as a human being put manual efforts rather than automation, and that basically impacts the productivity, as we have to put additional efforts across different environments. We, as I said, right, we are performing same iterations again and again on different environments. So that basically led to too much manual activities, and thus it cause like there is high potential of human errors. Long development cycle. So with no or minimal focus on automation testing, multiple iterations of manual testing happens on multiple environments. So it all starts from the local developer environments to the central development server, then maybe to the quality or testing, environment. And then once UAT is performed on that quality environment, then actually it is rolled out to production. So there is a long development cycle, and as I said, right, it leads to huge delay on the overall solution development and its deployment, and this basically leads to increased cost of ownership. I mean, to maintain all these things, you need multiple resources. Then whether it is hardware, infra, or human resources with different skill sets, so it's overall it's a very high cost of ownership. So considering these challenges, we have an option. I mean, DevOps is something, it's not specific to Teamcenter. It's there since ages. So what we can do, like we can leverage this DevOps concept and we can integrate this with Teamcenter, and we can reduce these challenges, or like we can minimize these challenges to a greater extent. So to in this regard, the one of the important tool that we have to understand is Teamcenter Deployment Center. So basically, the challenges we basically went through, I mean, considering the complexities and other things, what Siemens did, like they introduced this new tool, Deployment Center, which is centralized, web application for deploying all your softwares, to these Teamcenter environments. It gives you basically access to multiple environments from a single centralized location. So as an administrator, I don't have to hop between multiple environments or machines or windows to look the same configurations. Here in this centralized environment, I can just simply analyze all the environments.
All the environments.
Excuse me, there is some echo. Can you please go on mute? Yeah. Okay. So so this gives you a central view to uh, manage all your environments. It basically simplifies the process of installing and updating software. So here in this same window, we have access to update our softwares and basically to it basically, as I said, right, it simplifies the process of installing, and we'll be seeing like how it is like being done. And secondly, like you can manage variety of Teamcenter environments. So whether uh, uh, you have like for example, I have to maintain my both SSO based and non SSO based environment, or so I can have I mean, it's just the same environment, but it's just the uh, uh, deviation is with the SSO and non SSO, so I can quickly kind of copy the environments with without SSO, and then I can then start the deployment. So uh, typically, when you do the deployment center uh, installation, so this is the view. Let me just quickly log in. So this is the view that you get it by default. You uh, log in with the, I mean, DC admin user and with the default password. You can change it. So here on this machine, I mean, here on the screen, you can configure your environments. You can uh, uh, basically add your software repositories. You can also add the machines. Uh, uh, so this is quite similar to our Active Workspace client. It has a resemblance to it, and it has similar, I would say, look and feel. So if I go to software repositories, it will show me all those repositories, repos, we call it as, that I have currently used. So like for example, Active Workspace, then the currently I am having 6.2 and 14.2. So for that, whatever softwares I need, so that I have selected in this active media. Then if in case you have obsolete media, like which is not used or removed, so you will see it. And in the overview, like on the machine on which you have used this repos. Then the machines, it's the machine on which you have kind of configured your repositories, so that you get it. And then environments is, as I said, right, this is the environment that uh, which gives you the I would say a unified or common view to look for all those environments those are being used. So for example, here you can see I have selected the development environment, and if I look at the status, it's kind of installed, and of course it's additional details like what are all those components that I have installed as a part of this development environment. So of course, I mean, deployment center itself is kind of another installable, I would say, installer tool with which you can uh, map your variety of deployment related requirements. And with the latest release of uh, I guess 14.3, there are additionally there are there are some use cases which are being now supported, which were not supported by the earlier versions. So as a part of our today's session, right, we would be seeing deployment center along with additional DevOps, tools. So we'll not have much focus on the deployment center as such. I mean, as I said, right, deployment center itself is another application, and you can like we can do various use cases. We can map various use cases, but today our focus is like using DevOps along with deployment center. So we'll move on that point. So the when it comes to advantages of deployment center is like as I said, right, you can manage and maintain multiple versions of software in the multiple Teamcenter environments from a single web application. So for example, if let's say you have kind of uh, I mean, you are in process of upgrading your Teamcenter, and you want to kind of uh, create an environment with the new, with the new latest release. So now you can build your I mean, just to check the features and the like kind of new features in the release, you can build it from the scratch, and you can kind of create an environment, and you can view it in this location. Then it reduces the overall cost of managing Teamcenter environments by reducing number of people, resources, steps, and manual efforts, time involved in the software deployment. Since the core concept of deployment center is basically generating artifacts in the backend, and kind of which are nothing but the scripts in simple language, and execute those scripts in I would say a non-GUI manner or without any human intervention, so that these scripts are executed by themselves, and then kind of you basically at the end of the process, you get basically your software installed. Then it provides a centralized location to create and view Teamcenter environments, to view the deployment information. It ensures the consistency and accuracy, by reviewing and adjusting deployment configuration before rollout to Teamcenter environment. So you can always check or validate your environments before actual rollout, uh, to the environments or to the machines. Then moving to the next topic, that is something that we would be discussing today, is like DevOps. So as I said, DevOps is not something which is specific to Teamcenter or which is new. It's there, and it's being widely used by other, I would say, enterprise applications or other, uh, 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 other uh, products or other softwares, and it's being actively used. So DevOps basically it's a combination of the word development and operations. So that is why it says DevOps. So it's basically it unites people, process, and technology in while uh, 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 while you develop your application. So it all starts from planning, then development, and delivery and operations. So basically, you plan like how to develop your solution, uh, how it should be performed, how it should be used, what are all those use cases that should be considered. Then you develop, right? So as per your requirements, as per your plan, as per your expectations, as per your acceptance criteria, you basically develop these solutions. Then you deliver. Uh, uh, so which means like actual after the development is done, you actually deliver, which means you deploy, and then you operate. So operate in the sense like you maintain. So whether it is monitoring of the solution, issues, bug fixing, so you basically maintain. So this DevOps basically it basically, I mean, at a high level, like it does these four things. So it's an I would say framework or that basically encourages faster and better application development, and it demands basically for the faster release of updated software features, or we call it as product updates, right? So with the DevOps, you get your product updates on the faster, uh, like with faster release, and it basically helps customers to to remove or like to fix the critical issues or bugs which are part of the existing system. So this closer relationship between DevOps, I mean the development team and operations, right? It basically leads to I would say a quality product which is delivered to actual end user, to customer, and then it basically ultimately it basically brings the a desired ROI. So when it comes to DevOps, the important thing that we have to consider is the what are all those DevOps practices that typically are used. So when it comes to DevOps practices, uh, continuous integration and continuous delivery. So we call it as CICD. That is one of the I would say important uh, uh,
practice that we follow. So this is basically this practice basically spans the planning and coding phase of the DevOps cycle. I mean, I'm talking about the continuous development or delivery. uh, and then the continuous integration is basically it brings the various other tools together, uh, which basically ultimately builds and test the code and or like the artifacts which are ready for the production. It also involves the rapid feedback between the testing and the development team to quickly identify and resolve code issues. So CI/CD is kind of one of the important practice of DevOps. Then version control. So like any other software, I mean, uh, versioning or like source code management is one of the critical aspect of any software development. So with latest tools like GitHub uh, or Azure DevOps, so you can have this version control. Agile software development. So this is again one of the critical part of the DevOps. Like if you are working in DevOps, so your software delivery should be agile based, not on the waterfall based. So in a given you know uh, in a given, I mean, the based on the agile concepts, in a given specific time, you have to deliver the features which are uh, like developed with quality, and users can actually start utilizing the benefits. So agile based software development, continuous monitoring. So you have to monitor your solution. So you can use various tools like uh, Nagios or sort of it to monitor your solutions. Uh, uh, Planning, so you can again use other tools. So for example, uh, uh, a proper kind of uh, uh, a planning related tool, kind of maybe Jira or sort of it, right? That can be used. Then development, so actual development, so you will use various tools, IDs and other kind of softwares which are being used by the developers. And then which the other things which are related to operations and delivery. So this is something, it comes to the maintenance part of the product. So for all, I mean, for each of this practice, you have uh, n number of tools in the market which you can use for that specific purpose. And out of this thing, or out of these practices, the important one, or the one that we would be discussing today is CI/CD. Okay. Of course, you can as I said, right, you can evaluate or check various tools for all these practices, but the one that we would be looking today is it will be for CI/CD. So uh, with these I mean, as I said, like with the focus on CI/CD, we'll see like how we would be integrating this CI/CD along with deployment center, and then we'll see some of the business use cases. So coming back to the DevOps again, the benefits. So I mean, faster uh, and better product. So, I mean, we know faster and more frequent delivery of updates and features. It not only satisfies the customer, but it also help uh, uh, you know uh, to build that confidence in the product. Then uh, stabilized environments. So with the new feature, I mean, with the subsequent updates and features of the product, your environment gets stabilized quite uh, often, and then there are very less chances of having major issues. As I said, right, maybe kind of whether it could be performance issues or data conditions or any other data issues. Then significant improvement in the product quality. So closed collaboration between development and operation teams. It basically uh, you know uh, it is used to I mean, this close collaboration, it basically leads to a significant improvement in the quality because, uh, uh, I mean, because of the, I would say communication and this, overall practice, it becomes very helpful for the team to, to kind of build a quality product. Then automation. It basically so DevOps has one of the, I would say, important benefit is automation, as compared to traditional model where most of the things are are done by manual efforts or like by human efforts, and there was like very I would say no or very minimal scope for automation. But using DevOps, maximum things are handled through automation, and then it basically uh, saves, I mean, it improves the productivity, and ultimately it it leads to, I mean, it leaves more room for the innovation. Then continuous delivery of the software. As I said, right, in DevOps methodology, uh, as a part of DevOps, right, whole team is responsible for maintaining the stability of the product and offering new features. So the speed of the software is fast and undisturbed, I would say, unlike the traditional method where it used to, like, it takes more time, or like there is a delay in the overall development. And then of course the minimal cost of production. So with proper collaboration, DevOps basically helps in cutting down all these management and production costs of your departments, and this basically leads to I would say very low cost of ownership. So this is the typical I would say DevOps cycle you would have seen in various articles, and these are the list of I would say tools. Those can be, I mean, those probably would have used as a part of DevOps. I mean, of course, this list is not limited to only these tools, but this is just for our reference. Like you can use various these kind of tools to implement your DevOps. So one such tool that we would be today seeing is Jenkins. So what is this Jenkins? So Jenkins is a self-contained open source automation server. So ultimately what it does, so it is basically used to automate all sort of tasks which are related to build, test, delivery, and deployment of software. So whether in simple language, build means whether if I mean I assume some of you, or like most of you, are from development background. So building means like if the whatever artifacts you are having, whether it is code or sort of it, right? So you compile that code, you build it, then you test, you perform the auto test. So whether it is Xunit test, whether it is maybe Selenium test or any other kind of auto test, you test it through automation, no manual testing. And then once if the tests are successfully passed, then you deliver it, and then you deploy it. So that is the kind of typical flow of this automation servers. Uh, so Jenkins, one of the advantage of Jenkins is like it can be installed on any machine. It only needs the JRE. It's I mean, it's developed in the Java language, so you need only JRE. And with that, you can start your Jenkins automation server. And the other advantage it has, like, it provides thousands of plugins to support this CI/CD process, so like build, test, deliver, and deploy. So Jenkins is not the only tool. As I said, right, there are other alternatives for Jenkins in the market, and you can evaluate that as well. But uh, since Jenkins is widely used by most, I would say, by most applications or products across globe. So, like, our focus is on Jenkins. So as I said, Jenkins, it has its own set of benefits, some of which we already discussed. So it's an open source tool. So there is no as such cost that we have to bear. Portable and platform independent tool. So since it's developed in Java, so it's not something which is specific to any which is specific to operating system or platform. Like it is kind of independent, easy to install and configure. I mean, I mean, it's not that difficult. You can just by having few sessions or like just through a walkthrough Jenkins documentation, you can install it. Uh, as I said, right, it has huge, support for the other plugins. So plugins, when I say plugins, which means I mean to say the tools or those yeah, I would say tools which are basically used to perform this automation efficiently. And then integration. So you can integrate Jenkins with other tools as well to have a better to have a better clarity or view. So here you can see, right? I mean, this is with this. There are various at all those stages. You can see there are various tools that you can use. So, for example, when it comes to code and commit, so you have GitHub, Stash, then Azure DevOps, Visual Studio, Eclipse. Those kind of tools you can use while coding. If when it comes to build and configuration, you can use Maven or Gradle, Docker, uh, Ansible. When it comes to auto test, so you have Selenium, Sonar, Cube, JUnit, Cucumber. Uh, so scan in the sense like to check the uh, uh, codings and I would say uh, just to ensure the code is uh, honoring or adhering to the standard guidelines. You basically do the scan. Sonar is basically used. So likewise, there are other tools. So for release, you have other tools for releasing these, uh, uh, your build, and finally deploy. So for deployment, again, you have these tools like Docker, then OpenStack kind of tools which you can use. So the important part that we would be seeing today is like CI/CD pipeline, Jenkins CI/CD pipeline. Okay, so a Jenkins pipeline is basically suite of plugins. It's basically suite of plugins which supports the implementation and integration of uh, uh, continuous delivery pipeline. So uh, here you can see this is typical syntax of a Jenkins pipeline. Uh, so continuous delivery, right, that we were talking about. So continuous delivery pipeline is an automated expression of your process. So which means like it's a automation of your process of getting software from the source control to the actual deployment to the end users, right? So this is a complete process. So right from fetching out the code, source code from your repos, then the build, then the test, and then deployment to the end user. So this complete process, if we consider this complete process, so this continuous delivery, right, pipeline is an automation of that process. So Jenkins pipeline is kind of wrapper to this, uh, CD pipelines. Okay, internally you have the CD pipelines, and Jenkins pipeline is a wrapper on the CD pipeline with which you can then configure. So these pipelines basically, add a very powerful set of automation tools on top of it, like a Gradle. So for example, if you want to, as a part of your, customization, you have used various third-party libraries, and you need a robust mechanism to build all these third-party libraries, which should be integrated with your code. So Gradle is one of the tools that you can use, and which basically ultimately leads to a full automated, I would say, process for this. So what we would be doing is like we would be integrating this Jenkins CI/CD pipeline with deployment center. So basically our job is to work with the deployment center, generate all those artifacts. Those are necessary for us to deploy that solution, and then integrate them with Jenkins, and then perform your kind of job. So that's what we are seeing here in this slide, right? Implementing DevOps in Teamcenter. So we have to start with the identifying all those deployment use cases to be implemented through DevOps, right? Then we should be aware about the deployment center to generate necessary configurations, or I would say the artifact files that I was talking about. Then integrating Jenkins with the deployment center, building the pipelines and executing them, and at the end, like reporting. So reporting in the sense like which baseline or like which software, which environment has successfully deployed, or like what are the issues, open issues, and sort of it. But again, this is not something limited to these points only. This can be again extended to the greater, I would say, greater features of overall DevOps. So you can see, right, here is my deployment center where I have created various environments, and likewise, I have created pipeline for all these environments in the Jenkins, and uh, I would kind of so I mean in the backend I have kind of integrated this DC with the Jenkins, and through Jenkins dashboard only, I would be kind of performing my use cases. Okay, so let's start with some of the use cases that we will be discussing. So let's say I want to set up single box dev environment. This is one of my scenario. Now, what could be the background? Let's say customer has started to implement Teamcenter, and developers are continuously they're checking the artifacts or source code in the central repository. Let's say GitHub. Okay, and let's say because of multiple data model changes uh, from different developers, there are like issues have occurred, and a new plain Teamcenter installation needs to be set up, okay, with the predefined data. So and this is something, it could be applicable to the local developers environment. Let's say you have a team of 5 developers who are having their respective Teamcenter installations, their own database and Teamcenter installation, and you want to set up a fresh right from scratch, but of course with some predefined data. So that is a scenario. Again, there could be one more scenario with this, like you have a team of developers or customizers, and recently let's say 3 new developers have joined your team, and you want to make sure that you are you want to make sure that you are allocating Teamcenter environments to them. So these are kind of scenarios where you need you should have an option to automatically deploy your Teamcenter, and with no human intervention. So with the of course with the legacy approach of manually installing Teamcenter and all needed templates, and with that data, it might take one complete business a day. And if it is multiple developers or multiple machines, so it will take some more time. And uh, I mean, for big customers where you have huge customizations projects are going on, or where you have a huge code, or there is a high frequency of code commits. So here you would have probably you would have seen that these issues are quite often. So here, if we do this through a deployment center and Jenkins, I mean through a proper CI/CD pipeline, we will have this complete process through automation, and with with all those steps. So that's what we'll quickly see. I mean, of course, we cannot see the complete flow in this session because of the time constraint, but just to give you the glimpse like how this process could be, I have edited this video, and we can see it. But as I said, right, concept wise, or actually, this will do the things that I have told. So let's say this is my Jenkins dashboard. So I have logged into Jenkins. I will be logging to Jenkins. Probably some of you are already aware, but in case you are not aware, so this is my Jenkins homepage where I will log in. So here you can see this is the pipeline I have created. So here you can see I have created 4 different pipelines. Uh, so first is like setup Teamcenter BMID codeful deployment. So this is for if I want to do BMID deployment, that too with some code. So this script or this pipeline I will execute. Then single box, if I want to set up a development environment, right? Single box, the use case that we were talking about in the presentation. And let's say I want to set up Teamcenter production environment with a distributed, kind of environment, like on with different machines. So these are the pipelines that I had created. So you can see here. So here what I'll do, I'll be opening this Teamcenter development environment single box. Let me just open this. Sorry. It's not allowing me to, you know, okay, let's just, yeah, uh, it's not allowing me to, drag that progress bar of the player. So let's just go the video. So yeah, these are the pipelines that I was talking about. Then here the another important thing is the nodes, but that is something we'll see in the distributed. Here you can see, right? I clicked on this build executor status where it is actually showing the nodes. So what is this nodes that we'll see in the next video. But this is again important part of the Jenkins. So I've clicked on this single box environment pipeline, and I have clicked on this play button. So you can see a new so when I click on this build now, so I want to run this now. So you can see a new job has been started. So if I click on this, and if I just see, you can see what I'm doing internally. I'm kind of, as I said, right, I'm calling all those or I have integrated all those scripts. So this is something I'm doing through quick deploy, the feature of deployment center. So I have created configuration file for this quick deploy, and this configuration file I'm kind of reading, and I'm kind of performing the environment. Now, as I said, right, I have kind of edited this video with the certain steps. So you can see one of the tasks of deployment center is running 23 of 92, and internally, which basically it is executing the command which is business modeler updater, which is the step command of 58 of 79, which is internally getting called by the deployment center, right? It has nothing to do with Jenkins, but it is being deployed by the, I mean, it is being run by the deployment center. And at the end, you can see, right, deployment center has been completed. Now, post deployment center is done. So let me just, take a pause here. Post deployment center is executed. Now, since we had selected 4-tier client in my configuration in my deployment center, so that is why it has automatically built the tc.var file. So now through this pipeline, what I will do, I will be deploying my TC war file on the Tomcat server, and then it will start the Tomcat server. So my web application file tc.while it will be deployed. I will start then pool manager, right? Since I need to validate my environment is successfully installed or not, I'll be starting Teamcenter pool manager. Then So this is something I have optionally kind of added. I mean, I have put this message starting X unit testing. So even though I'm not running here any test cases, this is I'm just simply executing script. I'm in the utility install AYT and it is showing site is already installed. So which means like at least this utility is running. But as I said, right, you can extend it to the full-fledged auto test. So you can write a test like both CPP or JUnit test, or for that matter, you can also write this uh, uh, Selenium test. So in case if you want to check active workspace client, so I can write the Selenium test and I can then log into active workspace and I can just validate the scenario, maybe just broad brush testing. And you can say like, okay, I could able to successfully log into Selenium, and probably you can write this kind of message, and then post that uh, like you will see the deployment is complete. Okay, so here in this pipeline I had three stages: deploy, then I mean the build stage, build, then deploy, and then a test. Second stage was test, and the third stage was deploy. So with this I should be able to see the Teamcenter. So you can see, right, my Teamcenter is installed here. So these all these paths I had given in my configuration file through the quick deploy script. And if I go to my installation, and you should be able to see the DC folder if you have installed through deployment center. And here you can see all those task list where you have kind of I mean, it will show you list of all those components which are installed and its status. So with this, what we have done, we have kind of uh, installed a simple, I would say, Teamcenter on a single box environment, right? So the next, and of course, yeah, I mean, if you log in, try to log in, then you will be, you should be able to log into Teamcenter. Right. Then the second use case is distributed production environment. Now this is something I have not done it because of course we like I mean since from the hardware point of view we don't have that all those separate components, but this is just for understanding how it can be like how it is done. Uh, so of course, production environments, it can be on, I mean, for most oftenly, it is on distributed environment on multiple machines where you could have multiple pool managers and separate machines for active workspace, gateways, indexer, web application server, visualization, in fact, load balancer server. You can have various components. So with this deployment center and Jenkins, I can process this again through automation. So here in the deployment center, I'll have to make sure that I am generating all those scripts, for that machine only. So I mean if you're able to recall, right, in the earlier UI of deployment center in the environments, when I'll create the environments, I'll have to make sure that whatever machines that I have configured in the deployment center, those should be mapped as nodes in the Jenkins, so that through Jenkins scripts and through Jenkins, I can redirect those specific jobs on that specific machines. Right. So that's what here, we have done here. So again, this is kind of this production distributed. Let me just, yeah. So here, what we have done, we have configured this Jenkins pipeline in such a way that, the the machines which I have configured in deployment center, on those scripts will be executed on a specific node. Okay, so here I have done that mapping. Okay, so for example, one node will be active workspace gateway. So through Jenkins script, I will make sure active workspace gateway should be installed on this node. Likewise, I have pool A, corporate server, pool B, then Teamcenter database server, web application server. So this mapping, we have to make sure that these hosts are same, so that I should be able to run those scripts on those specific nodes, right? So this again is possible through this Jenkins. So again, similarly on the similar line, you can do these things. So if you run this pipeline, uh, so if I go to, yeah, I just go to the status. Right, so target environment is my production, and here I can then again. So this is now something a deployment center is not having control. This is completely driven through Jenkins, which will based on your configuration, it will redirect that specific job to be done or to be executed on the target node. So as I said, right, if I want to, let's say, deploy the pool A, so it will be deployed on the pool node which is identified as pool A. Okay, then again, let's say I want to install active gateway, active workspace gateway, so it will be installed on a machine of that gateway only, right? So this is again can be performed like through for the distributed machines. Then the last use case is like deploy BMIDE codeful customization. So where code commits and data model changes are being pushed in the central repository. Now administrator wants these changes to be deployed on the server, on the central dev server or any server for that matter. So again, I will write a pipeline which will call those specific scripts, and uh, additionally I can use tools like uh, you know uh, Gradle or sort of it to manage build, right? So here you can see I have created this pipeline setup Teamcenter BMID codeful deployment. So here when I'll click on it, yeah, so I will start the job. So again, with the latest, deployment center, you can do the, BMID deployment from the deployment center itself. So that's what we have used here. Now this package contains, as I said, some codeful, customization. There are certain extensions. So let's quickly see like. So it has started the BMID deployment. So you can say it has set the necessary environment which is required for building up your code. So you can see for this project I have generated the code. It's compiling the source code. So this was one of my extension. So you can see it has successfully built the libraries and the DLLs, and you can see it is like done. So then the next thing is generating BMID package, right? Once the uh, like template is ready, you have to generate the package and then you deploy that package to the Teamcenter. So of course, through that script, internal scripts only, we can do the deployment, and finally you can kind of do your further stages. So in the testing stage, maybe you can do regression testing just to check whether any critical or like common use cases are working or not, right? So in this way, like you can build these various kind of pipelines, and you can kind of automate this, Teamcenter, deployment steps. Right. So that was it from my side today. Uh, like within like we tried to cover both deployment center and Jenkins, considering the timeline and other things. But again, as I said, right, this is not something limited to the use cases that we discussed. And with actual, environment, customer environment, this is kind of, again, this, I mean, the scope changes, and like you have to kind of work in detail. And last but not the least, right, I mean, these kind of programs we typically do with our other organization, which is our resource development, PLM solutions, where we do these kind of programs like DevOps, Teamcenter DevOps, and likewise cybersecurity, active workspace customization, TCRA, AIG, Active Integration Gateway, ECAD and CAD integration, supplier collaboration. So thank you for your time, and like I'm, thanks for joining this session. If you have any questions, queries, and we don't have time, but let's see if we could take